Here in Shuttle Launch Control, we're going to sit down and take a minute with Ken Tenbush, the flow director for Space Shuttle Endeavour, and talk a little bit about the flow and getting ready for the mission. Ken, thank you so much for joining us today.
Thank you very much. It's very good to be here.
How have things been going?
So far with the count tonight has been absolutely fantastic. Very smooth. Really no issues to talk about. It's just proceeding as expected.
Excellent. Now I understand that you have a video that you'd like to show that's going to go through the count or go through the flow. That's going to explain a little bit about the process, and we can talk about that.
Okay, very good. Sounds good. And here you go. You got Pegasus, the barge, coming in, and it's actually shipped from Louisiana all the way around the tip of Florida, where it comes up the waterway into the turn basin, which is about a quarter mile from the VAB. And you can see the tug right now pulling the external tank off of that tug. They roll it into the vehicle assembly building. And the ET itself is very amazing. That's the liquid hydrogen tank that you're looking at right there. And that's the LOX tank. The tank itself is 154 foot long with a 27 foot diameter, and it weighs empty only 57,000 pounds, but when it's loaded up, it's 1.6 million pounds. And you can see some folks right here. They're doing some digital X-rays on some different areas on the liquid hydrogen feed line, the LOX feed line, and also on the pressurization lines, and verified that we were all clean of any debris there. Here we are in the orbiter processing facility, and you got some techs that are taking some photographs of some tile, some damaged tile. They were getting some 3D imagery to be able to construct a tile for replacement. And here we are in the payload bay. As you can see, the finishing touches being completed in the payload bay as it gets ready for getting ready for a payload installation. And here we go with the installation of the boom. That boom winds up getting installed on the right-hand side of the vehicle, and when they actually go up on orbit, the arm on the orbiter then mates up to that boom, and then they're able to get a good scan on the underside of the vehicle during the mission apps. And here we have the engine being installed, engine number 1 being installed in the aft of the orbiter. And we actually refurbish the main engines every single flow and reinstall them. Here we've got breed tile being installed on the external tank door. We install these hardened tiles around the ET doors and also around the main landing gear doors and the nose landing gear doors. Very rigid, hard tiles in those critical areas, making sure that those areas are protected. And after a good 4 or 5 months, we wind up rolling out of the orbiter processing facility and take that short trip over to the vehicle assembly building. The vehicle assembly building is 525 foot tall, but here we go. It's they're going about 2 miles an hour in the short journey over there, and the transporter itself has got 76 wheels, so it's a very interesting piece of ground support equipment that we have here at KSC. You can see we're behind you, Endeavour. I love that sign as the orbiter's rolling into the VAB, getting positioned for 2 different hooks that wind up going in, picking up that orbiter off the transporter. And then you got this 325-ton crane lifting the orbiter up and over a transom into the integration cell. We've got the external tank and the 2 solid rocket boosters waiting there. The orbiter itself is 122 foot long, 78 foot wide. It's a lot bigger than it looks, but yeah, it's very huge. Here they've got everything mated, put together, and now they're ready to roll the crawler transporter out of the vehicle assembly building. The crawler transporter itself is 6 million pounds, and it gets 150 gallons to the mile, so maybe not the best gas mileage. And it's a long journey out to the pad. It takes about 7 hours, 7.5 hours to make that journey out there. And here we can see the mobile launcher platform being set on the stanchions out at pad B. Again, it's a very careful process trying to get that all laser aligned perfectly in position so that they make sure that when they do have to mate up the arms like off the fixed service structure, that everything's lined up properly. And you can see that work being done there. Here we got the folks doing all the connections into the mobile launcher platform. There's close to 400 connections that have to be made it into the mobile launcher platform. You've got hydraulic, electrical, comm feeds. Recently, there was quite a bit of fiber optic lines that were also a first time that we've used to make sure that we've got good comm between the vehicle and back here in the launch control center. And here we are at the pad B. We went through a really good flow at pad B, getting the vehicle ready for that particular mission. In that particular case, we were there for the possibility of launching a rescue mission for STS-125. So we were out there waiting for a short launch between that launch if required. Everything went very well. And then what had happened was STS-125 actually got rescheduled to a later date because of problems up on orbit. So we were then ready to make that roll back around to pad A. We had another 6.5, 7-hour journey from that pad to the other pad. Gave an opportunity for the folks to work a lot of different modifications out at pad B. They're going to get that ready for an Ares 1 test flight that'll be coming up late next year. Again, the vehicle's making that long journey back over to pad A. Maybe a good opportunity here just to maybe talk about some of the good effort that was made by all the different teams that put that vehicle together. It was a fantastic flow across the board between the orbiter processing teams and the external tank and solid rocket booster teams, and those two words pretty much say it all. Go Endeavor. We're ready for a launch tonight and looking forward to it.
Well, that's fantastic. Thank you, Ken. Now, I had a question. Now, how long exactly does it take for a flow to go to get get the shuttle ready until the next launch?
Yeah, the orbiter itself, it takes on the order of about 4 months to be able to do get all the work as far as deconfiguring that orbiter and getting it then ready. Like, for example, the engines that we refurb every flow, just to name a few things. But yeah, there's quite a bit of work that's done there in the orbiter processing facility to get it ready. On the external tank side, it's on the order of about 3 months from the time that we actually get the external tank here before it's actually ready to launch. So all that's kind of coming together. You're processing the external tank as you're processing the orbiter. And then you got the solid rocket boosters that we also process, and that's done about the same amount of time that it takes the external tank. So you're kind of putting all those three particular processing flows together. We integrate it all in the integration cell, and then you've got a month out at the pad, and then you're ready to launch.
When you said that it is a team effort, so could you tell me about how many people it takes to do a flow?
Uh, that's a very good question, to say the least. There are, I want to say, on the order of about 100